good to be with you once again. I want to believe that you can hear me clearly and also that you can see the screen clearly. Okay. In our previous class, we talked about the different treatment processes for crude oil and the reason or the benefits of refinery upgrading. We discussed that and you were given some assignments to submit, which I want to believe that you've all responded accordingly by submitting or doing those assignments and submitting them too. Okay, so today we'll be looking more critically we'll be looking at two aspects. What I plan to do, first of all, I promised in the previous class that I was going to show us exactly what happens inside the distillation column, maybe through a video. Now, for time's sake, the video is about 70 minutes. I would give you a reference for that video, but I'll just show you some parts of it to illustrate. Then we'll talk about the various processes more deeply that we have in the oil and gas industry. Okay, so just sit back, please pay attention, and watch this for a few minutes. I mean, be skipping some parts of it, because of time. All right. So just watch. Thank you. Please pay attention. Take note of some points that you need to, or as you need to, and
process plant distillation system. It's important for operators to understand how distillation systems work because it's part of their job to make sure the systems run properly. The purpose of a distillation system is to separate a liquid mixture into two or more components. Separation takes place in a distillation column or tower. The liquid mixture is called feed or charge, and the components into which it's separated are called cuts or fractions. Let's take a look at a simplified representation of a distillation system. In this example, the feed is stored in a tank. During operation, a pump is used to move the feed from the tank to a preheater. In the preheater, the mixture is heated under pressure to just below its boiling point. The pressure in the tower is lower than the pressure in the preheater. So when the feed enters the tower, it starts to boil. The vapors from the boiling liquid, which primarily contain the lighter components in the feed, rise in the tower. The remaining liquid, which consists primarily of the heavier components in the feed, moves down the tower and collects at the bottom. Some of this liquid is drawn off as the bottom's product. Some of it's routed to a device called a reboiler, which is connected to the bottom of the tower. The reboiler is usually a heat exchanger that's designed to vaporize the lighter components that remain in the liquid at the bottom of the tower. Vapors from the reboiler, or in some cases, a mixture of vapors and liquid, re-enter the tower. The vapors then rise up the tower. These vapors and the heat they contain are often referred to as boil-up. The hot boil-up provides heat that's needed for the distillation process to take place in the tower. The vapors that rise up in the tower are routed to a condenser. The purpose of the condenser is to cool and condense the vapors into liquid. From the condenser, the liquid flows into a receiver or accumulator. The receiver provides a reservoir for the liquid. Part of the liquid from the receiver is pumped back into the top of the tower, and part of it is drawn off as the tower's overhead product. Well, we've just looked at one simple example of the distillation system. Not all distillation systems are the same, but most of them have the basic equipment that we've just seen. At the heart of a distillation system is the distillation tower. Basically, a distillation tower is a series of distillation processes, or stills, stacked on top of each other. Distillation is sometimes referred to as fractional distillation or fractional concentration of lighter components and a lower concentration of heavier components. So this is how the distillation process is repeated on each tray as the vapors rise through the tower. Now, not every distillation tower is designed in the exact same way. However, every tower can be divided into three basic sections. The middle section is where the feed enters the tower and part of the feed vaporizes. This vaporization is commonly known as flashing. So this section of the tower is often called flash zone.
So you've seen the flash zone. Because of time, I will just be cutting it intermittently. What you see inside here are the trays, and it's showing you how the fluids get to move inside the column. Okay. Now the middle area, we call it the flash zone. You have the rectification section where you have lighter components.
Or below the flash zone is called the stripping.
Then you have the stripping section. We have the heavier components.
Lighter components are vapors or stripped from the heavier. The distillation tower works quickly would produce pure product. Fortunately, that's not the case. The lighter product usually contains some heavier fractions, and the heavier product usually contains lighter fractions. This is sometimes referred to as overlap. The distillation system uses several methods to help maximize the purity of the products. One of these methods is called refluxing. Vapors off the top of the tower are condensed in a condenser and then collected in a receiver. Part of the liquid from the receiver is sent to storage or to other units in the plant as the first overhead product. The rest of the liquid is pumped back into the top of the tower. The liquid that's reintroduced into the tower is called external flux.
Alright, so I'm pausing it at this point of reflux, just to, I believe we are all reminiscing some of the things we've said or learned in our previous classes, where we talked about the collection of lighter products at the top of the fractionating column, and where it is cooled, and then or how it is usually cooled and compressed, because you have to collect them in liquid form, because they are gases. Basically, they are majorly gases. All right. So we'll come back to this much later. I just wanted us to see this illustration and then go back to our main topic of discourse for today. All right. So here we have it. Some of the accomplishments we have from the upgrading of refinery. I need to make this screen bigger. Okay. So now the emission of pollutants. I've explained earlier that one of the reasons for upgrading refinery is that we want to achieve a cleaner atmosphere, a cleaner environment around the refinery area and even beyond. Now, what does this mean? We're trying to cut off as much as possible all forms of pollutants that could emanate from the refinery. So that's one of the purposes for, amongst many others, for upgrading refinery. So this graph you see here was a compilation that was taken from the period of 1994 to about 2003, and we looked at the different tons per year of emissions that were being gotten from refineries. Okay, and it was analyzed that over the years, with the introduction or with the practice of refinery upgrading, we've been able to try to cut down on the emissions, the releases, the content that is released to the air. You know, most of these contents are through um, the flaring of gas. All right. Now I explained that when a refinery or in a refinery, the gas line where we flare excess gases that are gotten or that cannot be compelled or compiled together. One of the things that they do is that they flare them. Now, in the course of flaring it, these gases are usually laden. That laden means they usually contain some level of crude oil in them. Now, as a result of the presence of this crude oil in these gases or some oil content in these gases, you now have a flame that is being produced at the flame, which is poisonous to the environment because you have a lot of in the in that flame or in that soot during the combustion. So what do? We try to see that whatever gas that is going to the flare line in the process of refinery, we ensure that such products are free of gases. They have been scrubbed off. I'm sorry, of crude rather. They are free of crude. They've been scrubbed off the crude. The crude oil content that they have. All right. So the emission of pollutants from oil refineries decreased significantly over the past decade. That's between this period of 1994 to 2003. I can't lay my hand on the more recent readings, but it will definitely be a decline if you look at refineries that have been upgraded. You understand? Over the past decade, due to the new technology implemented into the oil refinery techniques. All right. So it is very important that we take note of that also. That upgrading the refinery helps to reduce that. Now we talked about the different treatment processes in the previous class, and some of the solvent treatments, how you can um, remove heavy materials and waxes from um, from a mixture of crude by using some particular form of solvents. Okay, those solvents will help crystallize the oil and take off the oil. One part dissolves, the other part does not dissolve. That's just the process by which it works. Okay, so in the end, you discover that those heavy materials or those heavy fractions or contents, like the waxes, can can be separated by using what a solvent extractor. All right. So this is just a schematic view or a diagram, a process flow diagram illustration of those processes we discussed in the previous class. All right. So overall, overall, this is what we have as a generic process. If you remember, in our previous classes, we've talked about some several processes like um, first we talked about the distillation, which certainly we have different types. We have the fractional distillation, we have the vacuum distillation, and all that. Then for the other processes, we talked about coking, we talked about cracking, breaking down of heavier hydrocarbons into smaller molecules, which may be in higher demand. And most times is to meet up with the supply. We also talked about reforming, and some of you who those of you who have done organic chemistry before, you may be familiar with the term isomers. When we talk about isomers are um, hydrocarbons which have the same molecular formula, but they have different what structural formula. That in terms of molecules, they have the same number of the same number of carbon atoms, the same number of hydrogen atoms, but in terms of structure, they may not really look the same way. Okay, an example is hexane. Hexane, an isomer of hexane is um, three three methyl three methyl butane or pentane. Sorry, yeah. 3 methyl pentane is an isomer of hexane, for instance. It if you look at all of them, and both of them rather, they have the same structural formula or different molecular formula. So that process of creating isomers is also known as what? Isomerization. Isomerization. All right. As you can see in the or on the screen rather, you can see that we have a whole generic process for everything that happens from the crude. The injection of crude into the fractional distillation or into the distillation column. Then we have collection of the liquefied petroleum gases, and then we send that crude, the crude distillate. We have them at the up. We have vacuum it. We now take the bottom product for vacuum distillation. Now, we have the vacuum distillation process taking place here. We have the naphtha hydrotreating taking place here at this point where we have the upper content or the lighter product being collected. Now, the middle product, the mid distillate, we also take them through a process called mid distillate hydrotreating. Okay, so each of these processes we're talking about the hydrotreating, isomerization, vacuum distillation, coking, alkylation, and the rest of them. Now, even under cracking, we have the different types of cracking. We have the hydrocracking, we have the catalytic cracking, and the what now? Thermal cracking. The same thing, even under reforming, we have the catalytic reforming, and uh, we also have under alkylation. Then we have under cracking, there's what we call the FCC, the fluid catalytic cracking. Okay, so you can take a snapshot of this. You're still going to get the um, material for further study, but this is a schematic uh, representation of the whole generic process that we have. In the end, you see us having different products. Even hydrogen is taken up, we have the gasolines and aromatics. Aromatics are those compounds that contain ring hydrocarbons like benzene, you know, and they usually have some kind of smell or pleasant smell rather. Then you have the jet fuel and diesel. You have our gasoline, that's petrol and the rest of them. You have them all collected at different after this whole processes. Okay, so we've talked about the simple process, but we're now going a little more complex into each of these processes. Now, each of these processes that we've mentioned, let's see they how they go, what they entail, what is involved in each of these processes. The first we are looking at is our CDU. Our CDU means crude distillation unit. You know, crude oil distillation unit. This is a schematic of it, but I'll first want to explain this. Now, what's the objective of the distillation unit process? First of all, is to what? Distill and separate the valuable distillate from the crude. What are valuable distillates? Those those fractions that are in high demand in the market, are in high demand. Examples are what now? Your petrol, that's your gasoline, your naphtha. Naphtha is used. If you remember, we've talked about the use of this product for various purposes. Please, for your own interest or in your best interest that you master what the fractions of crude oil distillation is and their uses, even possibly the range of temperatures at which they are what separated. Okay, now you should understand that by now. We've discussed this before. So the main purpose of the distillation unit process is to first of all distill or separate all the valuable distillates. And when we're talking about the valuable distillates, we are looking at the content fractions like naphtha, which is used in production of several chemicals, and even especially in the medical industry too, it's also very important. Then we also have kerosene, both your dark purpose kerosene and your jet fuel, they belong to the same class. Then you have your diesel or your atmosphere gas oil or fugitive gas oil, which is AGO, from the crude stock. Then the primary process is a complex what now? The primary process technically complex distillation, like we have earlier seen, you know. And now, what are the individual processes? First of all, you should understand that by now. So when you are asked to explain the process of crude oil distillation, for instance, you should know the steps that are involved in it. Number one is what to preheat the crude feed, utilizing what recovered heat from the product stream. Now, product stream is a stream, is the line that is carrying the crude oil into the distillation unit. Okay, then we carry out desalting and dehydration. The desalting is to remove all salt content and sulfur content that are in the crude, and the dehydration is to remove the water content. In Let me quickly say this. You might not see this in this material. In the dehydration of crude oil or in the dehydration process of hydrocarbons, there are two basic compounds that are usually made use of. It's we call them TEG and MEG. TEG means tetraethylene glycol. That's TEG. That's just for your um, knowledge sake. Just have that at the back of your mind. Okay. Then the other one is the monoethylene glycol. Yeah, monoethylene glycol. The monoethylene glycol is usually both of them are used for the dehydration of hydrocarbons. We try to take away hydrates. Hydrates are water components of compounds that may be present in the crude oil. They can lead to corrosion or enhance corrosion. They also are impurities to this crude oil. You understand? So you can't have water or hydrates mixed with oil and you want to run it in your engine on your system. So you have to take that off. You have to scrub that off. So in doing that, you make use of those compounds. That's how that has back on. All right. So the hydrates, back to what we're saying. So one would dissolve and dehydrate the crude oil. We do that using the electrostatic enhanced liquid-liquid separation. That's what that equipment. The liquid-liquid separator is what we call the dissolver. Okay. Then we heat the crude to the desired temperature using what fired heater. That's heat exchanger. Now, if you remember very well, we said earlier that there are two basic factors that are responsible for or that allow the distillation of crude oil. Now, one of them is what? I can hear the temperature, and the other is what? Now, their molecular weight. Never forget that. Temperature and what? Molecular weight. The difference in their temperature, sorry, not temperature, not just temperature, boiling point. Their boiling point and what? The difference in their molecular weight. Now, the boiling point is talking about the point at which the atmospheric um, pressure will be equal to the vapor pressure, the point at the temperature at which the substance begins to boil off or convert to vapor. All right. So now, at that time, because you have difference in their temperature, so when this crude is heated up, you discover that and is run through the distillation column, like you saw in that video. You discover that what now? Those ones that have the lighter components, they have very low boiling point. So as the temperature is increasing, those lighter components are already going up the fractionating column to be collected at the top. You understand? Those are the top distillates. All right. So as the temperature increases, those that have light molecular weight, they usually have lower boiling point. Okay, so they'll be the first to be collected. They'll be the first to escape from the crude oil that is launched into the distillation column. So what do we have? We have what now? The flash. First we heat the crude to the desired temperature using the fired heaters. Then we now flash the crude in the atmospheric distillation column. We've already seen it in that video when we talked about the flashing. Okay. Then we utilize pump around cooling loops to create what internal liquid reflux. Now that's what you saw in the fractionating column in that video that we just played a few minutes back. All right. Then the products draw are on the top, side, and what bottom. So we'll be having what this means is that the different fractions will be collected. Some will be collected at the top, some will be collected at the side. Those are the side. Then we have ones collected at the what now bottom, like you saw in that video. So this is what it looks like. All right. This is a schematic view of what we're talking about. We have the crude coming in here, pump, and this is the preheater. Then this is the desalter. The desalter will remove all the salt content in the crude. You know, those ones are collected at the bottom and brine. All right. Then the crude oil is further sent through the heater to to the atmospheric furnace where it is heated. So that heating process now before it's sent to the fractionating column. You know, at the fractionating column, we now have the collection of different products, like you can see here. So you can see that you are getting atmospheric gas, you're having naphtha, you're having kerosene, then you're having diesel, you're having AGO, just like that, different products. And then you have the reduced crude, the heavier products now are collected at the bottom. So that's just a simple illustration or diagrammatic illustration of what happens in the crude, in crude oil distillation. So when you are asked to explain crude oil distillation, the examiner is expecting to see things like this. After you explain the step, you can draw either a process flow diagram or a schematic view, something of this nature, to show how the distillation occurs in a crude distillation unit. All right, very important. Okay, now we have the VDU, another form of distillation, which is the vacuum distillation. Part of your assignment that you are getting in this class, one of it is for you to explain and illustrate all the forms of crude oil distillation process. Okay, it is all the forms of what now? Distillation processes that you have. Because you are going to be explaining them. All right. Now, the vacuum distillation, um, the vacuum distillation process is got to do with the main objective is trying to recover those gases that are very valuable from the reduced crude through vacuum distillation. Remember something here. We ended at this place. Look at it here. At this place, at the bottom, after the first stage of crude oil of distillation, we usually have heavy products collected, which we refer to as what? Reduced crude. Reduced crude because we've already taken some fraction of it. But that does not mean that this crude does not still contain some of these fractions that we have taken. It still contains some content of some of the fractions that we've taken away, but not as much as the initial crude that was introduced here. Follow the cursor. Follow the cursor. So not as much as what now? The crude that was introduced here. So we have such. So we have the reduced crude now is the next thing that will take into the vacuum distillation column. So what we try to do is that from that reduced crude, from this reduced crude here, we want to collect as much as possible, collect the valuable gas oils, the valuable gases and oils or products or fractions that are in that reduced crude. And the process of doing that is known as what? The process of what? Vacuum distillation. Now, what's the technique actually involved? And any of these processes that we have in the oil and gas industry, please understand something. There are three major areas that you always see me talk about. Number one is what? The objective of the process. Number two is what? The primary process technique. And then the steps that are taken to achieve that process. The objective of the process, the primary process technique, and the steps taken to achieve the process. Why am I emphasizing on this? When you are asked questions or when you see questions of that nature, what the examiner is expecting of you is that you are able to explain your answers in this form. Does not mean that you must always put it, you must just list them like this. But in your explanation, you are making a summary or explaining, hitting on these three major points of what? Objective, then technique, and what? The steps. All right. So now, what's the technique involved in vacuum distillation of crude oil? The technique involved is what? To reduce the hydrocarbon partial vapor pressure or partial pressure through vacuum and stripping stream. So you pass that hydrocarbon content through a vacuum or a stripping stream. A stripping stream is a stream that will be helping to take off a fluid channel that will help take off, that will be taking off those contents that we find valuable. If you take them off the crude, if you absorb them off the crude, so that's what I mean. So we take it through what now? A vacuum, and we're able to, or a vacuum and a stripping stream, and we'll be able to what now? Extract the content that we need. All right. Now, what's the process? What's the process steps like? The first thing is that we heat that reduced crude to the desired temperature using fired heaters. So that reduced crude here is heated to a desired temperature using fired heater. You are going to see the diagram or the schematic very soon. So then we flash that reduced crude in a vacuum distillation column. We utilize pump around clean loops like that, the same thing. And products are drawn from the top side and bottom. Just the same thing that still happens in your fractional distillation column. The same kind of process will happen in the what now? The vacuum distillation column. So this is what it looks like. This is the produced crude that we have here, which was the bottom product that was collected at the first stage of the fractional distillation. Are we together? All right. So it is passed through what now? It's passed through the furnace so that it is further heated. And then you discover that you're able to get other products now from the column. So you are having this LVGO, you are talking about the lighter vacuum gas oils and the heavier gas oils also that are collected at the side. Then at the top we have the jet, the jet fuel, the kerosene. Like remember I told you that there will still be some of those. Why we call the content that is entering here reduced crude is because there will still be some of the products that have been collected in the first stage. Some of them will still be in this reduced crude. So it is recollected now or further collected at the top product when this crude is made to pass through the vacuum distillation unit. Okay, like you can see here, we're saying to vacuum jet. So what we have in this area is those kerosenes and gas oil that we have as the top product in this case. Then as the side product, we'll be having the heavier gas oils and the lighter gas oils. Then at the bottom, we have the residue. Okay. So from there, we go to another process under the coking process. under the cooking process, remember we talked about cooking before. We have the delayed cooking process. All right. Now, quickly, I'll be giving you some assignments. I want to believe you can still hear me clearly. I'll be giving you some assignments. I'll just dictate them. Please take note of them. I might not be able to show them now on the screen. I just have them for you to take them for you. So please take note of these assignments. You are submitting these assignments on or before the next class. Before the next class. That's you're submitting it latest on Wednesday next week. Latest. So number one assignment there is for you to, in fact, by Tuesday next week. Yes, Tuesday next week, 6 p.m. Tuesday next week. Now, the number one question there is for you to list, explain, and illustrate all explain, and illustrate all forms of crude oil distillation process. All forms of crude oil distillation process. Number two, state the typical yield and disposition of each of the process. State the typical yield and disposition of each of the processes. Then number three, explain the following with illustrations. Explain the following with illustrations. Number one, or Roman figure one there is delayed cooking process. Delayed cooking process. Roman figure two, fluid catalytic. Fluid catalytic cracking process. Okay, make that fluid catalytic cracking process Roman figure 3. Roman figure 2 is fluid cooking process. Remember, Roman figure 1 is delayed cooking process. Roman figure 1, delayed cooking. C-O-K-I-N-G, delayed cooking process. Roman figure 2 is fluid cooking process. Fluid, F-L-U-I-D, cooking process. Roman figure 3 is fluid, F-L-U-I-D, catalytic cracking process. Fluid catalytic cracking process. Then Roman figure 4 is hydrofluoric acid alkylation, HF. Alkylation. HF means hydrofluoric acid. Hydrofluoric acid alkylation. Alright. When you are sending it, send it with the subject OGM. Send it to engineerimar.jpts@gmail.com. engineerimar.jpts@gmail.com. When you are sending, send it with the subject. Use the subject OGM 213 assignment 6. OGM 213. I think that should be assignment 6. Yes. Assignment 6. OGM 213 assignment 6. Then put your name, the name of your center, and state. Okay, please ensure you do it as you have been told or as I've explained, because your failure to do that means you cannot pick up because they don't have a week ahead.